So for part A demonstration, I'm going to use this tall graduated cylinder and I'm going to layer it with 3 different liquids, and since they are different density and not miscible, you're going to clearly see 3 different layers. This is my first 2 layers, methylene chloride and water. And this is going to be my 3rd layer. So I'm going to add in a couple pieces. The first one is a glass topper. Goes all the way to the bottom. Next one is a rubber stopper. The 3rd one is a cork. Floats on the top. And the last one is a piece of ice. The ice keeps floating on top of the blue layer, which is the aqueous layer. Cork on the top, ice on top of the blue layer, the rubber stopper on top of the bottom layer, and the glass topper is down in the bottom. So for part B, we are measuring the density of water. We are going to measure the empty 125 Ernst flask with the stopper in 2 different balances, a centigram balance and a milligram balance. So make sure it's zeroed before you place your Ernst flask. So centigram balance, that's the mass of the Ernst flask with the stopper. And then we are going to place our Ernst flask in the milligram balance, mass in the milligram balance. So we are going to use a 10 milliliter pipette. All pipettes have a mark which exactly measures the volume that is indicated here. So it'll measure exactly 10.0 milliliters, and we are going to use a bulb to fill in the pipette and transfer the water in the empty Ernst flask. So you can rinse your pipette using a distilled water bottle. Now I have some DI water, which I am going to transfer 10 ml into the Ernst flask. So attach the bulb, squeeze the bulb, and then start filling up. When it goes past the mark, I'm going to quickly remove the bulb and stop it with my finger. So right now, as you can see, it's way beyond the mark. And now I'm going to let some air and drop it to the 10 milliliter mark. So that's exactly 10 milliliters. I'm going to go ahead and transfer it to the Ernst flask. Remember, we do not blow a pipette. There will be a drop of liquid in the tip. Now we are going to place the stopper and go ahead and weigh it in the 2 different balances. Place the Ernst flask. And that's the mass in the centigram balance. That's our milligram balance. We are going to go ahead and place our Ernst flask. That's our mass in the milligram balance. So part C, we are going to get the density of an unknown liquid. We are going to measure the mass of the Ernst flask with a stopper in the 2 different balances. So we're going to place it on the centigram balance. Now we're going to place our Ernst flask in the milligram balance. And that's the mass. So for unknown liquid, we have unknown liquid B, which is this red colored aqueous solution. I'm going to rinse my pipette with a small amount of the liquid before we can fill it up. So squeeze the bulb and fill in some liquid. And once you have some liquid in here, try to rinse the glass of the pipette with the liquid in there. Dispose it in a beaker. So now my pipette is ready to be filled up. So I do the same thing like I did for water. Squeeze the bulb and start filling up. And once it goes past the line, take the bulb out and then slowly drop it to the mark. That's exactly 10 milliliters. I'll go ahead and transfer it to the RMAT flask. So again, don't blow the liquid out. There will be some reminiscent liquid at the tip of the pipette. Now we are going to stopper it and go ahead and get the mass. So that's the centigram balance. That's the mass. And that's my milligram balance. That's the mass. So part D, we are measuring the density of a rubber stopper. First stop, we are going to get the mass in the two balances. So that's the mass. And we are going to get the mass in the milligram balance. So I have a 100 milliliter graduated cylinder. I'm going to fill it up with some DI water about halfway through. We got the initial reading. Now we are going to drop the stopper very gently. So I'm going to tilt it and then slowly let it drop. So part E, I'm going to use the unknown solid, which is solid D, which is this aluminum rectangular block. And if you take a look, width and the thickness is the same, and this is going to be your length. We're going to place it on the metric ruler in the manual and get the numbers for the dimensions. So you're going to place it on the ruler and mark it with a pencil so it's easier for us to read the length. We're going to get the mass of the block in the centigram balance, and then we are going to get the mass in the milligram balance. So for part F, I've got a rectangular aluminum foil. I'm going to place it on the metric ruler in the manual and get the length and the width. I'm going to mark it with a pencil so it's easy to record the number. So I'm going to fold it into a small piece so it can lay flat in the balance. Now I'm going to get the mass of the aluminum foil. So we're using the milligram balance. So that's the mass of the aluminum foil.